So the main gist of today that we're going to be doing, there's three main things, okay? First thing we're going to be doing is developing two forms of addition counting principle. We'll talk about that in a minute. We're going to find the probability of union of events, and we're going to find the probability of complement events. Okay, and I understand that you guys probably don't know what I'm talking about right now, but by the end of the lesson you will. Okay, so let's start off. It says the addition counting principle here. Addition, find the number of elements in the union. I don't know what they were trying to say here. Find the number of elements in the union of two disjoint sets. So this is the symbol for union, you guys. It's like a U, so that hopefully will help you remember it. The A union B, or the union of sets A and B, contain all elements that are either in A or in B. If A and B have no elements in common, they are called disjoint sets or mutually exclusive sets. So, good question. So, here's what I'm going to show you. I'm going to draw a picture for you so you can see. I have two sets of information here. Here's set A, here's set B. Notice they're not touching. They have nothing in common. So, these are considered mutually exclusive. Okay, now if they were like this, where they crossed over like a Venn diagram, then this area would be the repeats. Okay, these are not mutually exclusive. So when I'm asking for the union of all of it, so I'm going to take all the numbers, say I had 5 in here, and I have 6 in here, then my number of A union B, in this case, would be 5 plus 6 equals 11. That would be my number within the union, the total possibilities. Okay?
Wait, so then if they have 5
Yes.
and 6 in the other one, then it would probably be like polar.
So, good question. So, if I were trying to find the union of this set right here, say I had, and I'll get to you in a minute, Anton, hold on a second. I see your hand. So I have this. Say I have 3, 2, and 5. My union of these two sets, I would just be adding the 3 numbers together. Because 2 is already included in the entire thing of A here. So if I were trying to find the numbers for this, it would be 3 plus 2 plus 5 equals...
Even though there's 2 in each of them?
Yeah, this 2 is not counted in this big number 3. These 3, the 3 are here, have no B values, okay?
So when you add the 2 twice, though, since it's...
No, not in this case. Now, if I said A had a total of 5, if I said that A had a total of 5 and B had a total of 7, which is true, okay? Because 3 plus 2 is 5. B has 2 plus 5, and that's 7. That's when you got to make sure that you're not repeating anything. So you would subtract 2 from it. Okay?
Just count the middle step once.
Right. Right. Okay? We're going to get into that in a little while. So, but let's stay with me because all we're going to talk about right now is mutually exclusive events. Okay? Okay, so the probability of getting A, in this case, we have 5. What's the total number that we have? We have 11, right? So the probability of A in this case would be 5 over 11. And the probability of B would be 6 over 11. So if I added those together, my probability of drawing one of those would be 11 over 11, or you know you're going to draw one of them. Okay?
Wait, so what?
It's asking me what is the probability of A union B. Okay? So my probability of drawing an A, I have 5 total A, right?
Mm-hmm.
Over the total number of 11.
Yeah, wait, but my question is the union, is like A union B, is that the mutually exclusive?
Yes, this is still mutually exclusive. Yep. Notice it says it right there.
Wait,
A
so
here.
then what
What
is
is
this?
A? And
Why
what
did
is
you explain that the?
It says write the possible sums when two paired six-sided dice are tossed. Okay, and it already did that for us in this picture. They have the red dice and the green dice. And these are all the possibilities. And how many possibilities total do we have? 36 total possibilities. And it says, let each possible sum be an event. Find the probability of each event. Okay? So what I want you guys to do is to write a chart. And you're going to have to make it kind of small, but call it sum, frequency, and probability. You're going to probably have to make a couple of these. You're not going to have much room right here.
Wait, what? Are we doing part A or B?
B. Because part A was done in the picture for you. Those are all the different possible events. Okay. So our first possible sum is 2. How many times do you see the sum of 2 in the picture? One time. Okay? So my probability of getting this is 1 out of what? Out of 36. Okay? My sum of 3. What is my frequency of finding a 3? 2. And that's going to be 2 out of 36, or 1 over 18, right? How about the sum of 4? Yep, 3. You have a frequency of 3. 3 out of 36, 1 over 12.
1 over 12.
What's the probability? Yep. What's the probability, or my sum of 5, what's my frequency for that? 4. 4 out of 36, or 1 over 9, right? All right. How about 6? 5. And then you have probably 5 over 36, and you can't reduce that. Okay? How about the sum of 7? 6. And 6 out of 36 is what? 1/6. 8. No.
Oh, really?
We're going back down because 7 is the most frequent. So if you look and add all the ones that add up to 8,
Is some multiplied?
no, you're adding them. So like in 8, you can have a 4 and a 4, a 3 and a 5, or a 5 and a 3, so on. So this would be a 5, frequency of 5, 5 out of 36. Okay? How about the sum of 9? 4. Okay. 10. 3. You seen the pattern here? 11. And 12. 1. Okay? Okay, so you guys see the pattern. It goes all the way up and all the way back down. Okay, so for letter C, it says, find the probability of each of the prime number events. Add them to find the probability that the sum of the face-up numbers is a prime number. So,
Wait, you have a problem with prime number?
what are prime numbers again?
Okay, I don't understand that.
Yep, the number that can only be divided by itself and 1. So, what are our sums that are prime numbers?
7.
2, 3, 5, 7, 11, because those are prime numbers. They're not parentheses, I'm just putting quotes. No, 13 is not a sum on here. The highest you can get is 12. Okay? Okay, so those are our 5 possibilities. So what is my probability for the first one? 1 over 36. Okay, what's my probability for a 3? We'll keep them in 36. 2 out of 36. That way it's easier to add. 5. 4 out of 36. How about 7? 6 out of 36.
Wait,
And
are we only adding the count or
the ones that are prime, yep. 11, 2 out of 36. So if I add all these together, I get, you got 15.
Never mind.
Did I add it wrong? I had 17. 3, 4, 7. 7 plus 6 is 13. 15. It should be 15. Oh, I must have been sleepy. So 15 out of 36. Okay? Make sense? All right. When two events are not mutually exclusive, they have outcomes in common that are in the overlap, okay? The set of overlapping events of elements A and B are called the intersection of the sets, denoted as A intersect, it's an upside down U, B. Okay, so here we are. The first one is mutually exclusive. Notice that they don't touch. Okay? In this case, you're just adding the two together. The second one, they intersect. So they have some repeats in there. So this is where we're going to get to talking about what happens here.
So intersection, you just literally write down where it intersects.
Right. It's just that green section right there is the intersect section. Okay, so it says suppose Edina High School, at Edina High School, 298 students study only French, only Spanish, or both languages. Edina reports that 115 students study French and 209 study Spanish. But because 115 plus 209 is greater than 298, there must be students who study both languages. How many students study both?
Are you kidding? You add them on then.
Kind of, yeah. So there's a way to do this. There's a method to this madness. Let's do this. I'm going to make a Venn diagram. Okay, my left side is going to be French. You could just say F if you want. My right side is going to be Spanish. Okay? So we know that 115 students study French. Okay? And we also know that 209, I'm going to put that above the French, 209 study Spanish total. There are some students somewhere that do both. So I'm going to put an X there. We don't know how many students are in the middle, but we know that's an X. Okay? Now, to find out whatever is left after I take out that X, how would I write that in algebra right here?
115 plus 209 is that?
Well, no.
It would be 115
Yep.
plus 209 minus x equals 298, right?
Well, I'm not that far yet. I just want to know how many students just take French? Yes.
Would be 115 minus x.
Yes. Perfect. So that's what you would put there. Okay? How about just study Spanish? 209 minus x. Good. Okay? So now we want to find the number of students who study French or Spanish. Okay? F-U-S, fuss. Okay? So that would be the same as adding all three of these things together. Okay? So I'm going to have 115 minus x. Oops. Sorry, I'm going to erase that. 115 minus x is for my French, plus my union area right here. This section right here, that needs to be added to it. So plus x, plus just Spanish, 209 minus x. Yes?
Could you have like the French and Spanish and parentheses?
You could, yeah. So she's asking if, should we write it like this? Yeah, if it makes it easier for you to see that those are three different parts. Okay? So, and we know already that the total is 298. So I'm going to write that right here, 298. Number. Okay? Good question. So I'm going to have this 298. What are my like terms over here that I can add together? So I can add up 115 and 209, and that ends up being 324. Negative x plus x is what? 0, but I still have a minus x here. Now what do I do? Yeah, so I can take away 324 from both sides. And in that case, I end up with negative 26 equals negative x, which means what? 26 equals x.
So if you just, can you just add up the 2, then subtract up, and then subtract the
Yeah.
98?
Yeah, you could do it the other way. Yep.
Why did you go around the world? Yeah, why did you go? That's a good. I mean, like, we just went all over the place to come back to where we were. You don't
Yep.
get work on it.
I mean, algebra is, the nice thing about algebra is there's 100 different ways you can do it. Okay? Let's keep going.
You have to do 115 minus 26 to figure it out.
No, it just asks how many students study both, and that's what we got. 26 students. Now, if it asked you how many students study only French, what would you say?
Oh, then I would do 115 minus 29. Or
Minus 26,
minus
yep.
26.
Okay. All right, so let's look at example 2b. On this one, it says Jamie and Rhonda had to make up their FST test after school, and Mr. Murphy told them that they could come in no later than 3 and leave no later than 4. Jamie took 38 minutes on the test. Rhonda took 51 minutes. For at least how many minutes were Jamie and Rhonda taking the test at the same time? Okay, so this is going to be the same kind of thing, okay? We have Jamie
60 minutes.
and we have Rhonda. Yep, we have a total of 60 minutes, right?
Add up 51 and 38, and then we're going to minus them.
Okay, so we have a x here. We have 38 minus x here. Yeah.
Hey, wouldn't
Wouldn't it only be 38
Yeah.
because that's as long as minutes?
But they can come in later, you can come in at like 3:30.
Yeah,
For
somebody,
at least, not for like how many maximum.
so, yeah, at least, yep. So we're going to write this out just like we did last time. It'll be 38 minus x plus 51 minus x. Okay? So I have 60 equals 89 minus x. So if I subtract 60 from 89, I'm left with what? Yep, it's going to be 29. So the total minutes that they were in there together were 29 minutes. Anybody have any questions about this one?
Couldn't you just do 51 minus 38?
Yeah.
you know what I'm saying?
No, because they're sharing some. You got to look at the total time.
38
Yeah,
plus
but then you have to
51
minus-
minus 60.
And then you have to minus it by 60.
Yeah,
Well, 51 minus 38 is.
you just got lucky there.
Yeah, but sometimes it
Yeah. All right, so
Are you going to want us to like set it up like this? On the back?
it would be the safer thing. For finite sets A and B, A union B, okay, this is for the case where you have something that's shared, okay? When you have a shared section.
It's a finite.
Finite means it's a limited set. It has specific numbers in it. It doesn't go on forever. So when you have something that's shared and you're looking for the number of numbers in it, you're going to add A and B together, but subtract the ones that are repeated. So you're going to subtract that middle section. Same with probability. You would add the probabilities of the two, but subtract the shared ones. Okay? So turn the page. So, example 3A says a pair of six-sided dice is thrown. If the dice are fair, what's the probability that the dice show doubles or a sum less than 10? Okay? So, the probability of showing doubles. How many possibilities are doubles in our dice? 6 of them out of what? 36. Okay? What is the probability of throwing a sum less than 10?
5,
If you go back to that page, you can add them all up, right?
Because there's only 3 that aren't.
So, less than 10, you have 5 right here, right? That are greater than 10?
Wait, what?
Or, yeah, 6, right? 30 out of 36. Shh, shh, shh. Okay, look. How many do we have a sum of greater than of 10 or greater? Right here, right? There's 3, plus 2 is 5, plus 1 is 6.
Wait, but why are you taking frequency?
That's how many times it shows up. That you have the number of dice where you can add up a 10, 11, or 12.
Oh, okay.
Okay? So we have 6. So going back to this, the sum less than 10 is going to be...
Wait, I thought you said less than, so why are you taking greater?
because I'm taking it and subtracting it out of the total. So we have 30 out of 36. Otherwise I had to add up all those numbers.
Oh, okay.
Okay? All right, so what is the probability of getting a sum that is both a double and less than 10? So what numbers are double and less than 10? You got 1 and 1, right?
Is that D?
Yeah, doubles. And this is a sum, okay? So
2,
you have 2 and 2,
3 and 3,
3 and 3,
4 and 4.
4 and 4. Any other ones? No. So I only have 4 out of how many? 36. Well, 5 and 5 is how much? If you add them together.
It doesn't
Or a
say
sum.
equal then.
Doesn't it say or, not and?
Or some less than 10. Yeah.
Yeah, so when it's
So wouldn't it be 5 and 5 and 6 and 6? 5 and 5 and 6?
No, it has to be both for this part. I'm just looking at the intersection. Yep, I'm not there yet. I'm looking at where they have, where we're going to,
Oh,
where we're doubling up here, okay? This is the section that is in between both of these, right?
Wait, no, not 3 and 2.
Okay. So we already looked for our doubles. We have 6 out of 36. All the sums that are less than 10, we have 30 out of 36. These are where they're repeated, where they're in both piles.
Okay.
Okay? 1 and 1, 2 and 2, 3 and 3, 4 and 4. They're in both of these. Okay? So now what I want to do is add these together, 6 out of 36 plus 30 out of 36, but I got to take out the repeated value because they've already been counted twice. Okay? These numbers, 1, 1, 2, 2, 3, 3, and 4, 4, they were already counted in the doubles, and they're also counted in the sum less than 10, because 1 plus 1 is 2, 2 plus 2 is 4, 3 plus 3 is 6, and 4 plus 4 is 8. So they're one of those sets that are counted in this
So then
number.
it would be 32 over 36.
Yes.
Would be
32 over 36. Yes. Or 8 over 9, or if you were to put that in your calculator and find the percent, it's going to be like 88.9%. Okay?
89 or 88.9% of the time that it'll show doubles.
Yeah.
Or
Or some less than 10. So that's how many times that you have the probability of landing on it. Okay, number 3B, it says with the same dice, what is the probability that the dice show a sum of 7 or 11? So, first of all, let's find the probability of getting the sum of 7. Go back to,
1/6.
is it 1 6? Or 6 36, okay? What is the probability of getting a sum of 11? 2 out of 36. Now, Do these have anything in common? They're mutually exclusive.
How do you know? Because what the dice said?
The sum can't be.
Because the sum can't be both 7 and 11 at the same time.
Oh.
Okay? So these are mutually exclusive.
Wait, how do you know they can't be?
Because
They can't have different
what two
sums.
dice can be rolled that equal, when you add them up, equals 7 and 11.
Oh,
Can't be both.
okay.
Okay? So 6 out of 36 plus 2 out of 36 is what?
It's 8 out of 10.
8 out of 36. And if I were to actually, it would be 2 over 9, or I don't know what that is. And you could put it in your calculator, find the percent. Okay? For A. Any questions on that now? We're almost done, guys. We're getting there. 4A says, with the same dice, what is the probability that exactly one die shows up a 3, or the sum of the numbers is greater than 9? So, probability of rolling a 3,
It's 6 out of 36.
okay? It's more than that, actually, isn't it?
No? Oh, yeah.
I have 10 out of 36. Yeah,
How come she always gets to leave early?
not today. We're not done.
No, I can get my instrument.
Yeah, not today. We're not done. Probability of rolling a sum greater than 9. Six out of 36, right? Okay? So now we need to also find out our probability of rolling a 3 and rolling a 9. Sum of 9.
Wait, would that be union or the anti-union?
So this is our intersection sign, okay? Where do we have them in common?
Was the 3 3
Would
count
that
as
be
2?
upside down union?
Yeah.
Wouldn't 3, like the dice that's the roll is 3 3, wouldn't that be?
But they add up to be, that adds up to be 6, right?
But isn't it or? So it has to be up to 3 or greater than 9?
Where did the 7 come from? That's not a 7.
That's not a 7, it's a 9.
Right.
Okay, so, but there's no chances of rolling a 3 and the sum being greater than 9.
Exactly one die shows up. That happens 12 times.
Yeah.
Would that be? How many things do?
Okay? So, before you go on, I just want to, hold on, let's just talk about this part right here before the bell rings. You are not done yet, you guys, and if you don't hear me out, you're not going to be able to do this part. Okay, sometimes events are mutually exclusive and their union is the entire sample space. Such events are called complementary. The complement of event A is called not A. Okay, so for example,
Oh my God.
a complement. You literally need to stay.
Wait, you can't hold on to a different example if you didn't explain the last example.
I do it.
Hold on, guys. If I flipped a coin and I landed on heads, what's the complement of heads? There you are. Okay? That's what a complement is.
Whatever one of your groups is.
Yeah, it's the opposite of what you had. If I have the probability of 2/9 and I want to find the complement of it,
7.
it would be 7/9.